So before we talk about feature engineering, we need to know what is a feature. A feature is an attribute, and data is the key stuff. Features are derived from data. It is a measurable input that can be used in a predictive model. So below is an example of a Titanic data set. And what is a data set? A data set is a collection of data, usually presented in a tabular form. Each column represents a particular variable or attribute, and each row corresponds to a given observation of the data. Below is an example of Titanic data set, and there are some alternative terms for column, row, and value. For example, you can either say that it is a column or field or an attribute or variable or feature. For row, another term is record or object or instance. And you either say it is value or data. In predictive modeling, attributes of variables are the input variables, and the target attribute is the output variable, whose value is determined by the values of input variables and function of the predictive model. In this above example, the input variables are P class, sex, age, and the output variable is survived. What is feature engineering? It is a process of using domain knowledge of the data to create features that make machine learning algorithms work. And it is a machine learning technique that leverages data to create new variables that aren't in the training set. It can produce new features for both supervised and unsupervised learning. The goal is to speed up data transformations and also to enhance model accuracy. Take for example, below shows the flight status prediction, and you have date time combined column, and the other column is status. You will need to create a new column called hour of day column. Reason being, it will provide more accurate prediction on the status of the flight, since hour of the day is more important than the date and time combined. So for this case, you create a new column, and it's called hour of day to predict the status of the flight. And you may wish to remove this date time combined field. Feature engineering is a process of selecting, manipulating, and transforming raw data into features that can be used in supervised learning. All the values are numeric. So for example, male is transformed to value 1 and female is transformed to value 0. And feature engineering is the act of converting raw observations into desired features using either statistical or machine learning approaches. There are 4 key steps. For feature engineering. And the goal is to create and select features that will achieve the most accurate machine learning algorithm. The first one is feature creation. Creating features involves creating new variables which will be most helpful for our model. So for example, in the earlier example, I added a new variable such as hour of day column to do prediction. Feature transformation is simply a function that transforms features from one representation to another. And the goal here is to plot and visualize data, add new features, reduce features, speed up training, or to increase the accuracy of a certain model. The next step is feature extraction. Feature extraction is the process of extracting features from a dataset to identify useful information without distorting the original relationships. And this reduces the amount of data into manageable quantities for algorithms to process. Principal components analysis or clustering technique. They are examples of feature extraction. The fourth step is feature selection. Feature selection is a process of selectively reducing the number of input variables. And this is always desirable to reduce the computational cost of modeling, and it often enhances model performance. Features are sometimes more or less important to model accuracy or may lose the relevance in the context of other features. So feature selection algorithms analyze features for relevancy and functionality, use a scoring method to rank the features, and determine which features are most useful and deserve to be prioritized, and which should be removed for redundancy. This summarizes the entire feature engineering process. Firstly, you will then retrieve the data from databases, from internet. Once you've read in the data, you will then process the data, and then you will work on data wrangling. Next, you work on feature engineering and feature selection to select the important predictors for your machine learning algorithms. Use the different algorithms and you do evaluation of the different algorithms and you tune the different parameters. The best model will then be deployed. Importance of feature engineering. Feature engineering is a very important step in machine learning. It refers to the process of designing artificial features into an algorithm. These artificial features are then used by that algorithm in order to improve its performance. And data scientists spend most of their time with data, and it becomes important to make models accurate. When feature engineering activities are done correctly, the resulting data set is optimum and contains all of the important factors that affect the business problem. The outcome is accurate predictive models and very useful insights. Next, this section is talking about how do you work on missing data imputation. You can actually use pandas to work on the data imputation, or you can also implement the missing data imputation with scikit-learn and feature engine library. What is imputation? Imputation is to replace the missing data with statistical estimates of the missing values. And the goal is to produce a data set that we can use to train machine learning models. Below are some techniques to impute missing values for both numerical and categorical variables. So for numerical variables, you can use either mean or median imputation. And for categorical variables, you can use frequent category imputation. This part is on mean and median imputation. Mean and median imputation are suitable for numerical variables. Let's say we have the variable price that contains values in many of the observations. And it also contains a few observations for where the information is not available. For example, this orange part here, missing values. For mean imputation, we calculate the mean price for these values, which in this case is 76. And the median value for this case is 80. So you can use the mean value of 76 to replace the missing information. Questioning time. So when should we use mean or median to impute missing data? If you find that the variable is normally distributed, the mean or the median is approximately the same, and you may use any of the two imputation techniques. However, for variables that are skewed, either positively skewed or negatively skewed, you may use median to impute missing values. This is because the missing values tends to be influenced by the values at the far end of the distribution, and therefore the median becomes a better indication of the majority of the values. This part is on mode imputation. Mode imputation is frequently used for categorical variables. Let's say we have a variable that contains values such as Toyota, BMW, Fiat, Audi, and so on. We notice that the most frequent occurrence under the made variable is Toyota. Use mode of Toyota to replace the missing information in the missing values. So Toyota and Toyota here. You may ask yourself when to use mode imputation technique. You use it when the data is missing completely at random and no more than 5% of the variable contains missing data. For missing data imputation, you may use a feature engine library. This is a Python library with multiple transformers to engineer and select features for use in machine learning models. Feature engines transformers follow scikit-learn's functionality with fit, function, and transform function methods to first learn and then transform parameters from data and then transform the data. Feature engine library is an open source package. It allows you to create reproducible feature engineering steps and also smooth model deployment. It contains techniques to impute missing data and also to include categorical variable encoding, handling of outliers, and variable transformation. It allows you to implement specific feature engineering techniques to selected variable groups. To learn more about feature engine library, you can click onto this URL. And if you're using Jupyter Notebook, you can actually try to install the feature engine library. Advantages of feature engine library: it allows you to implement specific engineering steps to specific feature subsets, and it works with scikit-learn, and it allows you to design and store a feature engineering pipeline for different variable groups. So what is a pipeline? Pipeline is from getting the data, cleaning the data, doing the exploratory data analysis, modeling the data, and then gathering all the insights.